To our second polar coordinates video, and here let's just start with our toolkit, right? What's our toolkit to convert between polar coordinates and Cartesian coordinates and back and forth? Well, first we have r squared equals x squared plus y squared. There's one. And then we have the tangent of theta equals y over x, which is, I'm starting to realize, the slope, and sine of theta, right? R times the sine of theta is y, and r times the cosine of theta is x. And this is what we need to really go through these conversions, or I mean, these are very helpful to us. And the idea again is just that with the Cartesian plane, if you have x and y, right, the x value refers to left or right, our distance left or right, and the y value just refers to up and down. But with polar coordinates, we have this other idea where we want to find the distance we're going. Let me use a different color. We want to find the distance that we're going, r, right? That's what r is all about. Oops. R, there's a good color. R, and then an angle theta. Alright, so this is distance, and this is angle direction, right? Just that's the difference here between our systems that we're converting between. And we can look at a couple of examples. What if we had the polar coordinate, I don't know, 3, and then 120 degrees? Well, what is this? Let's get some intuition on that. This is telling us that we are going a distance of 3, right? Let's say this is 3, and we're going at 120 degrees. So here's 90, right here, and then we keep going. Here's 180, so 120, certainly not in the middle of 90 and 180, but a little bit closer to 90, so maybe like right here. And that's 120 degrees, right? That's the angle that we're traveling at from the x-axis, 120 degrees. And if we were drawing this right to scale, this distance right here would be 3. And that would take us to this point right here. So now the question is, well, what's that point on the Cartesian plane? What do we do? Well, this is, 3 is equal to r, and theta is equal to 120. So now we have all the information we need to generate our x's and y's. And how do we do that? Well, we know that r is going to equal x squared plus y squared, right? Theta equals 120, and tangent of theta equals y over x. Well, here is how I'm going to figure out my y and x values. So these two aren't that helpful, but these two right here are very helpful because we have y is equal to, y is equal to r sine of theta, so 3, that's r, times the sine of 120, and x is equal to 3 times the cosine of 120. And when you're entering it into your calculator, you want to really make sure that you're not in radians, but you want to be, in fact, in degrees here, I think. Let's check that out. So the 3 cosine of 120 equals negative 1.5 in our x direction, and that was in degrees. And for the y value, we did 3 times the sine of 120, and we get about 2.59. Let's say just 2.6. So we're saying here that to get to this point, you would go negative 1.5 this way, and then up 2.6. So this would be negative 1.5, comma 2.6. And that's the connection there. Now if you're entering this into your calculator and it's not working out, make sure, let's see what happens if we're in radians. 3 times the sine of 120 would be 1.74, and 3 times the cosine, let's try that, 3 times the cosine of 120 is 2.44. So that's actually a little hint, right? This point is in the negative quadrant for x values. So if you're getting positive values here for x, then there's definitely something wrong. So make sure you're in degrees for that. And there are other examples we can look at as well. Let me just change the color scheme here. Get that green background. trying it out. Alright, so what else can we have? Well, and what's the purpose of all this, right? Why even bother? Well sometimes polar coordinates make defining locations very simple. Let me show you an example. What if we had a function for, I don't know, x squared plus y squared equals 25. I hope you recognize this maybe as a circle. And if we graph this, right, we'd get a circle on the origin with a radius of 5. So let me highlight that. Anywhere we go in the circle, we're going a distance of 5. So it's 5 here. It's also 5 this way as well. And those are the measurements of the radius, which is the square root of this number right here, right? And that's how we define it in Cartesian coordinates. But what about polar coordinates? Well, again, our toolkit says that r squared equals x squared plus y squared. And, well, here's x squared plus y squared. So that's equal to r squared, and that equals 25. So we know what r is, right? R is the square root of that. It's 5. And that actually happens to be the radius in this case. And you might say, well, if we took the square root of 25, couldn't it be minus 5 as well, right? Plus or minus 5? The answer is yes, but it doesn't really matter. And the reason is, if we had gone in a positive direction, a positive radius, we'd go this way, and maybe our angle theta would be right here. But if we got in a negative direction, we'd just go negative. If we had a negative radius, like it's saying that r equals negative 5, we would just go in this direction right here. So, and that would be the same thing, right? Theta would be right here. These are equal angles. So r could equal negative 5, or r could equal 5. And in fact, what's interesting is we're done, right? The definition of a circle in polar coordinates is super easy. You just say, well, r equals 5, right? And that makes sense because what angle is a circle at, right? It's at all 360-degree angles around the origin, but it's always at a distance of 5. So if you want to define a circle in polar coordinates, you say basically every point, right, the collection of all the points that are 5 units away from the origin at all angle measures from the origin. So anywhere I go, 180 degrees, 270, I'm still 5 units away. If I keep doing that, I get a circle. So in polar coordinates, the equation for a circle could be just this. And this actually expands to other problems as well. What if I had, let me just change the color. If I had x squared plus y squared equals, I don't know, 16 y over x squared. And then we have our toolkit. We have r squared equals x squared plus y squared, and the tangent of theta equals y over x, and I'll leave it there for now. And then just by, r equals x squared over y squared, so instead of writing x squared over y squared here, we could say r squared equals 16, and then instead of writing y over x, well, the tangent of theta equals y over x, so we could write 16 times the tangent of theta squared. All I'm doing there is just substituting these values into our equation. And to solve, we could take the square root of both sides, and we get r equals plus or minus 4 times the tangent of theta. And again, this is the equation of a circle with a radius, or where r equals plus or minus 4, that doesn't matter, times the tangent of theta. And the plus or minus, that's not a very helpful circle. The plus or minus is just referring to the direction. I think it's going to be my best attempt at a circle on this one. Sorry about that. It's saying, well, the distance now from the origin is equal to either, let's say this is minus 4 or plus 4, right? And it's the collection of all the points that are at distance times the tangent of theta. That's still just going to give us a distance from the origin, and this is going to be the definition of a circle in polar coordinates. Again, in some ways much simpler than the setup of the Cartesian coordinates, and we're converting between them here, right? We're going, back and forth from Cartesian and polar coordinates.